All right, so now I want to talk about the ideas of increasing, decreasing, and constant. And these have to do with what a function is doing, okay? So a function that is increasing means getting bigger. So kind of colloquially, we say a function is increasing if it's going up. So for example, here is an example of a function that is increasing or getting bigger. Now in general, remember we work from left to right, so we mean getting bigger as we move from left to right. The formal definition of this says if x2 is bigger than x1, so if you've got an x value that's to the left of another x value, then f of x2 has to be bigger than f of x1. In other words, if I move from this point to this point, I have to kind of go like this. I have to increase or get bigger. Okay, how about decreasing? Well, decreasing is sort of the opposite of increasing. Decreasing means getting smaller. With a function, that might be something like this. This is a decreasing linear function. That means it has negative slope. And that means if we've got an x value that's to the left of another x value, then f of x2, our y value, has to be smaller. So in other words, to go from, say, here to here, I'm going to decrease or get smaller. And last, we have constant. Now, if a function isn't increasing and it isn't decreasing, it could just be flat or constant. So an example of a constant function is something like this. We're neither going up or going down, we're just flat. And that means that f of x1 equals f of x2, or our y values are the same. Okay? Now, we're again going to really focus on identifying increasing, decreasing, and constant from graphs, so from a picture. Now, when our graphs are straight lines, it's pretty easy to see whether they're increasing or decreasing. It may get a little bit more complicated when our graphs are curved, okay? So let's look at an example of an increasing graph that's curved. So an increasing graph that's curved might be something like this. Notice that graph is still getting bigger. It's still going up. A decreasing graph might look something like this. Notice that that graph is getting smaller as time goes on. Constant, pretty straightforward, stays constant. Now, one kind of back pocket tip that can be really helpful for deciding whether a graph is increasing or decreasing is sort of my hiking analogy. Imagine if you were walking along the function from left to right. We always walk on top of functions, not on the bottom of functions. Increasing means you're going uphill, right? So if I'm walking along this function, I'm going uphill. If I'm walking along this function, I'm going downhill. Sometimes instead of a person, we use a little ant. So if I draw a little ant, there's my little ant, he would be walking uphill on this function. He would be walking downhill on this function. And then of course he would be staying at a constant level. He's not going up, not going down on our constant function. All right, let's try and apply this to an actual graph. All right, so here's a function. Let's try and identify on what intervals this function is increasing, decreasing, and constant, okay? All right, well, I often think it's actually easiest to start with constant because constant just means our function is level, right? So hopefully you would agree that our function is constant right here, where it's kind of flat. Our function is constant right here. We often want to use interval notation to talk about where it's constant. So again, I'm going to use our x values. This function is constant from -2 to 1. So from -2 to 1. Now something that's a little bit weird when we're doing constant increasing and decreasing, we're going to do open intervals, meaning I'm always going to use parentheses. That's because right at these points, our function is changing from decreasing to constant or constant to decreasing or decreasing to increasing, and it can get a little bit confusing which one it is. So we're just going to use open intervals for this guy. Okay. All right, so there's where our function is constant, from -2 to 1. Let's think about where our function is increasing. So where is our function getting bigger as we move from left to right? Well, hopefully you can see that on this piece of our function, we're increasing or getting bigger. If it helps, you can draw your little ant and notice that if our ant is walking from left to right on the top of the function, he's certainly walking uphill. So let's write that as an interval. Remember, this arrow means that this is going to go on forever. So going on forever means all the way over there. I'm going to start at -infinity. And this is going to be increasing until we get to -2. And again, we're going to use open intervals, meaning we're always going to use parentheses. All right, Well, we did increasing, we did constant. Sure seems logical that this last piece of our function must be decreasing. And it makes sense. We're going down on this piece of our function. Our function is decreasing. A little ant would be going downhill if he was walking on top of the function from left to right. So let's write the interval for this decreasing piece of our function. This is decreasing from 1 to infinity. Okay, so increasing on negative infinity to negative 2, constant on negative 2 to 1, decreasing on 1 to infinity. Let's try another example. All right, let's take a look at this function. Okay, again, we're going to try and identify where this function is increasing, decreasing, and constant. Let's look for constant first. It looks like we're constant right here. In other words, my function is kind of flat right there. So let's write the interval there. That's going from x equals 1 to x equals 3. So we're constant from 1 to 3. And remember, we're using open intervals, meaning we're going to keep our endpoints open. We're using parentheses. Okay? All right. Now we have 3 other pieces that we need to deal with. This piece, and this piece. Okay? Where should we start? Let's work our way left to right. Okay? If we look at this piece, is this piece, certainly isn't constant, is it increasing or decreasing? So I'm pretty sure that this guy is increasing. A little ant walking on the top of our function would be walking uphill. So our function is increasing on this piece. So how would I write the interval for this piece? Well, it looks like this guy is stopping right here at negative 3. So I'll have from infinity to negative 3. So we're increasing from negative infinity to negative 3. Again, remember that we're using open intervals here. So we're increasing from negative infinity to negative 3. Let's look at this next piece of our function. What are we doing on this next piece? Are we increasing or decreasing? Remember that it helps to think that we walk from left to right. If I was walking, or an ant was walking along the top of this function, that ant would be walking uphill. So we're increasing here as well. Okay, so what's the interval here? Well, this starts at negative 3 and goes until 1. So our interval here would be negative 3 to 1. Okay, so negative 3 to 1. And the last piece of our function, what are we doing here? Are we increasing or decreasing? Well, that sure looks like it's going down. So we are decreasing on this little piece of our function. And that goes from 3 to infinity. Using open intervals, so using parentheses. So we're decreasing on 3 to infinity. And we said we were constant from 1 to 3. Okay. So again, this is looking at where our function is increasing, going up, decreasing, going down, or staying constant, neither increasing nor decreasing.